Hello students, we were discussing about for loops. So some more points that we should note about for loops will be discussed in this video. So we have noted that the for loop begins with a header for within brackets initializations, followed with semicolon, followed with test condition, followed with your increment or decrement. Now, it may be noted that the three statements, namely initialization, test condition, and increment and decrement inside a for statement, are optional. It is perfectly valid to skip any or all of this. However, there might be a few risks in doing that. So, let us see what are the problems involved in skipping any of these statements. So, for example, if the test condition is not given, then the loop will keep on executing itself indefinitely, as there will be no way of exiting from the loop. So for example, this loop for I equal to 1, for I equal to 1, then there is no test condition, and then I plus plus, the increment is given, printf %d \t I. So what will be the output of this code? It will be an infinite loop, and it will keep on printing 1, 2, 3, 4, that way endlessly. Why does this happen? The loop starts with I equal to 1, then there is no test condition. That means it is assumed that everything is true. So this particular statement printf is executed. So the value of I will be printed \t. Because of that, there will be a tab space here, and after that there is an increment operator also. So the value of I will be incremented by 1. Again, there is no test condition, so it will be assumed that the condition is true. So this printf statement will be executed again. So we will get 2 here. Then again, because of this \t, there will be a tab space here, and after that value of I again will be incremented. So see, at each execution, the test condition is always true because there is no test condition. So by default, it is assumed to be true. So the loop runs into an infinite loop. Okay, so let us see how this happens, or how does the infinite loop look like. Say program infinite for loop dot c. Okay, so let us see this program. hash include std io.h, then void main. Okay, so let us write one variable int I, and then we can write for I equals 1, no test condition, and then I give I plus plus, and then I write this statement printf %d \t, I. Okay, so let us run this program, see what happens. gcc prog inf for loop dot c dash o prog inf for loop. Right, so if we enter this, so it's compiled. Now we run this program, prog inf for loop. Sorry, I did some mistake here. Prog inf for loop. Yeah, it should be LWP. See, this is running endlessly. There is no limit. We cannot stop this process. Right, so what happens is it keeps on running indefinitely. It is still running indefinitely. Yeah, that way. So we can so we have to stop it forcibly. So here in the Linux terminal, we can press Ctrl C, it will close forcibly. So this is what is happening if we skip the test condition. Again, if the increment or decrement statement is skipped and the test condition is satisfied for the initial value of the counter variable, then also the loop will run into an infinite loop. Say for example, this one I equal to 1, I equal to 1 is the initialization, and I less than 5 is the test condition. So for the initial value of I, the test condition is true, but there is no increment. Observe that there is no increment statement or decrement statement here. And then it is followed with the printf statement %d \t I. So in this case, what will happen? Every time the test condition will be satisfied, but the value of I will remain as 1. So there is no increment. So this will keep on printing the initial value of I, that is 1, endlessly, because at each execution the test condition is always satisfied. So the loop can never be exited in such a situation. So let us see this case also. Let us modify this program and see what happens. For I remove this I++ and I gave here I less than say 5 printf %d \t I. Okay, let us compile this and let us run this program. See, 1 is being printed endlessly. So it's again running into an infinite loop. Okay, so we can close it forcibly. So this will yeah. Okay. The same happens when both the test condition as well as the increment or decrement statements are skipped. If we skip both the statements as well, then also there is a chance that the program may run into an infinite loop. For example, this program, for I equal to 1, there is no test condition, there is no increment. Okay, so everything is assumed true here, that the test condition is true, and the loop keeps on running itself. So this code, let us see this code, what happens for this. If we remove the test condition as well, then what will happen? And then you run this. So 1 will be printed endlessly, right? For I equal to 1, so initial value of I is 1, so that value is stored, and there is no test condition, so it is assumed that the test condition is always true, so the loop keeps on running. So the above code will also run into an infinite loop, and it will keep on printing 1 endlessly. So note that for a loop with all empty expressions, and a for loop with all empty expressions will also give an infinite loop. So if we write something like this, for I equal to 1, and keep these things empty, initialization, test condition as well as increment empty. So the syntax is not incorrect, but the logic is incorrect here. So this, if we run this program, then also you'll see it just goes into an infinite loop. Okay, so initial value is taken as 0 here. So in other computer, usually if a variable is not initialized, the compiler takes the value a random value or a garbage value by default. So usually in for loop in this system it has taken a 0. Maybe in some other system it may take some other value, and that particular value will be printed. Okay. So the above code will keep on printing hello. Oh, okay. I did this with hello. So if we write printf instead of writing %d I, if we write printf hello, it will keep on printing hello endlessly. Okay. So however, the test condition can also be included inside the body of the loop along with a break statement in order to exit from the loop. So there are several examples we will do, particularly examples involving prime numbers, where we will see that we do not give the test condition, but we give some condition inside the body of the loop using a break statement, which helps us in exiting from the loop. Okay, in that case, infinite loop is avoided. Also, the increment or decrement statement can also be included in the body of the loop instead of the header. Okay, for example, for I equal to 1, I less than 5, and then this we keep it blank, printf this, and the increment is included inside the body of the loop. This does the same work as this. These two codes, they have the same function. Okay, that can be done, right? So let us see one example. Program to display the factors of a positive integer using a for loop. Okay, so we want to find out the factors of a positive integer. So int and d, so we take two variables. sorry, there should have been semicolon here. This should be semicolon. Print n d, then enter a positive integer, scanf %d %n, printf the factors of %d are \n. Okay, and the value of n will be placed here. Okay, that is what we mean. So for d equal to 1, so the first factor of n is 1. So for d equal to 1, d less than or equal to n, the last factor is n. Okay, and every other factor lies between 1 and n. So d goes from 1 to n and increases by 1. But what we need to check is every number from 1 to n may not be a factor. Okay, a number d will be a factor if the remainder when n is divided by d is 0. So if n % d is equal to 0, then only then you print that d is a factor. Okay, so this will be printed. So let us see how it works. So what was that? It was program 11 for loop .c. Yeah, this is the program. What was that? Is it? No, factors of a display the factors of a integer. Okay. So let us write this program. Okay. int n comma d, and then printf enter n. Okay, and then scanf %d %n, and then we'll write printf the factors are the factors of %d are, then we'll give one \n. The output should come in the next line. This, and then we'll run the for loop for I equals d equals 1, d less than or equal to n, d plus plus, right? So we need there are two statements here, so we need a bracket. If n % d equal to 0, then you printf this %d \t comma d. Okay, if it is divisible, only then you print. Okay, so let us see how it works. GCC program 11 for loop .c -o prog 11 for loop. Okay, / prog 11 for loop. Okay, enter n. Say I enter something like 56. So what are the factors? 1, 2, 4, 7, right? 1, 2, 4, 7, 8, 14, 28, 56. These are the factors. Okay, say 3. The factors are 1 and 3. 2. Type 2. Factors are 1 and 2. Okay, like that. 100. What are the factors? These are the factors. Okay. 1200. These are the factors. Okay, so these are all the factors of the thing. Okay, so but the same program we could have. So here one thing to observe is that a number n cannot have factors greater than n by 2, right? Every factor, the highest possible factor of one other than n, the highest possible factor of n other than n is n by 2. Between n by 2 and n, a number cannot have any factor. So we can reduce the number of times this for loop runs by modifying our program this way. We start with we write the factor 1 separately and start with d and go up to n by 2, and then print n separately, right? So we just test what are the factors between 2 and n by 2. Okay, So the same program can be written that way. So that will decrease the number of times the loop runs. Okay, because it is not necessary to run the loop from n by 2 to n. Between n by 2 and n, the only factors are n and n by 2 only. If the number is even. If it is odd, n by 2 is also not a factor. So between n by 2 and n, there is only one factor, that is n. Okay, so just let us modify this. This program is also perfectly okay. It's just I am showing that we can modify it to, so here I will give one \t to d less than or equal to n by 2 d plus plus, and then another extra printf statement I have to give here because I need to print the factor n also. Printf %d \n comma n. Okay, so let us see what happens here. / program 11 for loop, so 56. So these are the factors, right? 3 factors are 1 and 2. So the same program runs in a different way. Okay. So this was about for loop. So in the next video we will be discussing the while loop structure, right? Thank you.